Hello students, in last few classes we have studied the real sequences, and in last 2 to 3 classes we have studied the Cauchy's general principle of convergence. Now, after proving the Cauchy's general principle of convergence and discussing it in detail, now we will solve some examples based on the Cauchy's general principle of convergence. So let us begin. So first example based on the Cauchy general principle of convergence is show that the sequence Sn where Sn equal to 1 plus 1 by 2 plus 1 by 3 plus and so on plus 1 by n cannot converge. Okay, so in this example we are going to show that the sequence Sn whose nth term is given as such is a non-convergent sequence. For that purpose, we are going to use the Cauchy general principle of convergence. So let us see how this can be solved. So solution of this example is, so first of all, it is given that sequence Sn is equal to the 1 plus 1 by 2 plus 1 by 3 plus and so on plus 1 by n. Now, if possible, let us suppose that the sequence is convergent. At the beginning, we are supposing that this sequence is convergent, and if we get contradiction at some stage, then it will mean that whatever we have supposed earlier must be wrong. So let us proceed. Okay, so in the beginning we have supposed that this sequence Sn whose nth term is given as such is a convergent sequence. Then sequence Sn satisfies Cauchy's conditions. As we know that every sequence which is convergent is always satisfies Cauchy's principle of convergence. So in the Cauchy's general principle of convergence, now we will put epsilon equal to 1 by 2, n equal to m and p equal to m. Okay, in the Cauchy general principle of convergence, we require epsilon, n, n and p. So here we will put epsilon equal to 1 by 2. We will take the particular value of n as the m as well as the particular value of p as m. Then from the Cauchy general principle of convergence, we will get mod of Sn plus p minus Sn less than epsilon. This was the term in the Cauchy general principle of convergence. Let us see how it becomes. So now we will get its value in this example as mod of n for the n and p we are putting m. So now it will become mod Sn plus p will become mod Sm plus m minus for Sn, for n we are putting m, so it has become Sm, and for epsilon we are substituting 1 by 2. So this is less than 1 by 2. Okay, so after this substitution we got mod of Sn plus p minus Sn less than epsilon as mod of Sm plus m minus Sm less than 1 by 2. But m plus m is 2m. So therefore we got mod of S2m minus Sm is less than 1 by 2. Next one. Now here we have Sm equal to the 1 plus 1 by 2 plus 1 by 3 plus and so on up to plus 1 by m. This is by the definition of the nth term of the sequence. So in that definition we have substituted m for the n and obtained Sm. Similarly, we can obtain the S2m. S2m means it is equal to the 1 plus 1 by 2 plus 1 by 3 and so on up to the 1 by 2m. But before the 1 by 2m, we will get the terms in between as 1 by m plus 1, 1 by m plus 2 and so on continued. So now we will take the difference of these two terms. So from the S2m, we will subtract the Sm. So we will get S2m minus Sm as, so S2m minus Sm means it is 1 plus 1 by 2 plus 1 by 3 and so on plus 1 by m plus 1 upon m plus 1 plus 1 upon m plus 2 and so on up to 1 upon 2m minus 1 by 2 plus 1 by 2 plus 1 by 3 up to the plus 1 by m. This complete is to be taken with the minus sign. Then after taking the differences, 1 minus 1 will get cancelled, 1 by 2 minus 1 by 2 will get cancelled, 1 by 3 minus 1 by 3 will get cancelled up to 1 by m minus 1 by m will get cancelled. And we will be left with only these terms right from the 1 upon m plus 1 up to the 1 upon 2m. So therefore we obtained s2m minus sm as equal to 1 upon m plus 1 plus 1 upon m plus 2 and plus so on up to the plus 1 upon 2m. Now, as we know that m plus 1 is less than 2m, therefore after taking the reciprocals of both the sides, we will get 1 upon m plus 1 greater than 1 upon 2m. We know that after taking the reciprocals, the relationship will get reversed. As we know that 2 is less than 5. But if we take the reciprocals, then 1 by 2, which is 0.5, is greater than 1 by 5, which is 0.2. So similarly is here. Okay. So therefore 1 upon m plus 1 is greater than 1 upon m plus 1 is greater than 1 upon 2m. So for the 1 upon m plus 1, we are substituting a term which is less than it, and that term is 1 upon 2m. Similarly, 1 upon m plus 2 is greater than 1 upon 2m and continued up to the last but one term, and the last term we have continued as it is. Now, which is equal to the, now each one term on the right hand side is a same term 1 upon 2m. So we will take 1 upon 2m throughout common. So these are m terms in all. So if we take 1 upon 2m common from each one term, then the remaining will be the 1 plus 1 plus 1 up to the m times. So these are m terms. So m times 1, summation of 1 m times is nothing but it is m. So it is equal to the m upon 2m, which is equal to the m will get cancelled and it is equal to the 1 by 2. So what we got? So therefore s2m minus sm is greater than 1 by 2. It is not equal to 1 by 2. Here, if we observe these equations and inequalities, then the strongest one is the greater than. So therefore we will get the greater than and not as the equal to. So therefore we have obtained s2m minus sm greater than 1 by 2. Okay. So if we will take the modulus. So therefore mod of s2m minus sm is greater than 1 by 2. But 1 by 2 was our value of the epsilon, as we have considered earlier. Epsilon was 1 by 2. So we got modulus of s2m minus sm greater than 1 by 2 means greater than epsilon, which is a contradiction to the Cauchy's general principle of convergence. Because if this sequence converges, then by the Cauchy's general principle of convergence, this quantity must be less than every epsilon. But here we are getting this quantity as greater than epsilon. So which means that therefore our supposition must be wrong. What we have supposed in the beginning? We have supposed that this sequence is convergent. So this our supposition must be wrong. And if this supposition is wrong, then obviously this implies that the given sequence cannot converge. Okay. So in such a way, we have shown that the sequence Sn whose nth term is given by 1 plus 1 by 2 plus 1 by 3 and plus so on up to the plus 1 by n cannot converge. Okay. So likewise, we can solve the example based on the Cauchy's general principle of convergence, and we can check whether the sequence converges or not converges. Students, we have solved one example on the Cauchy's general principle of convergence. Now we will move to the second example on the Cauchy's general principle of convergence, and this is similar to the earlier example. So we will solve. So example number second. Show that the sequence Sn, where Sn equal to 1 plus 1 by 3 plus 1 by 5 plus and so on plus 1 upon 2n minus 1 cannot converge. Here the nth term of the sequence is given as 1 plus 1 by 3 plus 1 by 5 and so on plus 1 upon 2n minus 1, means the nth term of the sequence is nothing but it is the sum of the reciprocals of first n natural number. First natural number, first odd natural number is 1, its reciprocal is 1. Second odd natural number is 3, its reciprocal is 1 by 3. Third odd natural number is 5, its reciprocal is 1 by 5. And likewise, if we go for the nth odd natural number, then the nth odd natural number is 2n minus 1, and obviously its reciprocal is 1 upon 2n minus 1. So here Sn is nothing but it is the sum of first n, it is the sum of reciprocals of first n odd natural numbers. Okay, so we have to show that this sequence cannot converge. So the process or the procedure to solve this is again same as that of the first example. So let us see. So solution of this. Here it is given that Sn is equal to 1 plus 1 by 3 plus 1 by 5 plus so on up to the plus 1 upon 2n minus 1. This is the nth term of the sequence. So if possible, we'll suppose that the sequence is convergent. This example also will solve by the method of contradiction. Means in the beginning we have supposed that this sequence is convergent. If we get contradiction at some stage, then it will mean that whatever we have supposed earlier must be wrong. So in the beginning we have supposed that the sequence is convergent. So if the sequence is convergent, then obviously it will satisfy conditions of the Cauchy general principle. Okay. So in the Cauchy general principle of convergence, we will put epsilon equal to 1 by 4, n equal to m and p equal to m. N equal to m is a particular value of n that we are putting as m. For the as a p was any positive integer, it's a particular value we are substituting as m, and epsilon is any positive real number. It's a particular value here we are considering as 1 by 4. So we may ask that why this in the first example we have considered epsilon equal to 1 by 2 and now we are considering epsilon equal to 1 by 4. As we know that epsilon can be any positive real number. So its a value we can take any its value as 1 by 2, 1 by 5, 2 by 10 or 2 by 7, anyone. So here this value of epsilon 1 by 4 is obtained by proving by continuing in this manner. Okay, so if you don't remember this value of epsilon, then later on also this value can be substituted here. So let us see. So in the Cauchy general principle of convergence, we have substituted epsilon equal to 1 by 4, n equal to m and p equal to also m. Then we'll get mod of Sn plus p minus Sn less than epsilon. This was the condition in the Cauchy general principle of convergence. So after these substitutions, this becomes mod of Sm plus m minus Sm less than 1 by 4. Okay, for the n we have substituted m, for the p also we have substituted m, as well as for epsilon we have substituted 1 by 4. So then we got this as mod of s to m plus m is 2m, so mod of s to m minus Sm is less than 1 by 4. That is, we will denote this one relation by the number 1. This is our relation number 1. Next one. Here we have Sm equal to the nth term is given by this formula. In this formula, we will replace the n by m to get the Sm. So we have Sm equal to 1 plus 1 by 3 plus 1 by 5 and so on plus 1 upon 2m minus 1. Similarly, S to m means the 2mth position term of the given sequence will be 1 plus 1 by 3 plus so on up to the last one term summation will be the plus 1 upon 4m minus 1. But before the 4m minus 1 upon 4m minus 1, we have the in between terms as 1 upon 2m minus 1 plus 1 upon 2m plus 1 plus 1 upon 2m plus 3 and continued. Next one. Now we will subtract this Sm from the S to m. So we will get. So therefore the S to m minus Sm will be equal to. So this will be equal to this S to m minus Sm. If you observe here, the first term in this one. So one will get these terms will be in the subtraction. And as we are subtracting Sm from the S to m, so 1 will get cancelled with minus 1. 1 by 3 will get cancelled with minus 1 by 3 and so on. 1 upon 2m minus 1 will get cancelled with the with the minus sign 1 upon 2m minus 1. So we'll be left with only this much terms which are m in number. Okay. So therefore S to m minus Sm is obtained as 1 upon 2m plus 1 plus 1 upon 2m plus 3 plus and so on plus 1 upon 4m minus 1, which is now greater than 1 upon 4m plus 1 upon 4m plus so on 1 upon 4m. Why? Because we know that as 2m plus 1 is less than 4m. As 2m plus 1 is less than 4m, therefore after taking the reciprocals, we will get 1 upon 2m plus 1 greater than 1 upon 4m plus 1. So due to this reason, so this first term which is on the right hand side, which is 1 upon 2m plus 1, so instead of that term we are substituting a term which is less than it, and that term is the 1 upon 4m. Similarly, for each one term on the right hand side, we are substituting a term 1 upon 4m which is less than each one of them. Okay, so this is equal to, so 1 upon 4m plus 1 upon 4m plus so on, this is m times 1 upon 4m. So we will take 1 upon 4m common from each one term, and we obtained 1 upon 4m into 1 plus 1 plus 1 continued up to the m times, which is equal to 1 upon 4m into 1 plus 1 plus 1 m times is simply m. So 1 upon 4m into m is nothing but m upon 4m. So m will get cancelled and it is equal to 1 by 4. So we have obtained s2m minus sm is greater than 1 by 4. Here sometimes we are having equal to and one times we are having greater than. So the strongest inequality here is the greater than. So we have to choose this one here. So therefore s2m minus sm is greater than 1 by 4. So after taking the modulus, we will get mod of s2m minus sm greater than 1 by 4, which was the value of epsilon. So epsilon we have considered as 1 by 4. So whatever the number we will obtain here, now that number can be substituted here if it is not mentioned in the beginning. Okay, sometimes we may get here 1 upon 10. So if we get 1 upon 10, then epsilon can be considered as 1 by 10 or any number which is less than it but positive real number. So likewise we can find out this value of the epsilon. Next one. Now we are getting the modulus of s2m minus sm greater than epsilon, which is a contradiction to the Cauchy's general principle of convergence. That is the relation number 1. This is a contradiction to it. Okay. So which means that therefore our initial supposition must be wrong. Our initial supposition was that the given sequence is convergent. So it must be wrong. And as this supposition is wrong, which means that hence the given sequence cannot converge. Therefore, in this second example also, we have shown that the sequence Sn, whose nth term is 1 plus 1 by 3 plus 1 by 5 and so on plus 1 upon 2n minus 1, it cannot converge. This is the second example. Likewise, it can be solved. So I am going to give you one example as your homework. So write down the third example as your homework, and this homework you are going to solve in your notebook. We have solved two examples on the Cauchy general principle of convergence, and this is a third example. Show that the sequence Sn, where Sn equal to 1 plus 1 by 4 plus 1 by 7 plus so on up to the plus 1 upon 3n minus 2 cannot converge. This is the nth term of the sequence Sn, which is given as such, and we have to show that this sequence also cannot converge. And to solve this, we are going to use again the Cauchy general principle of convergence. And this example is similar to the earlier two examples that we have solved. And this example is for your homework purpose. You are going to solve this example in your notebook, and you are going to find out the value of epsilon for which this Cauchy general principle of convergence here fails, and likewise we can show that this sequence also cannot converge.